Hello everyone, welcome for coming back to my channel. This is Toby, and yeah, this is promoting safety engineering. And today we're going to continue on our series talking about the last one I did was blowdown, shutdown, depressurization. That's the last one I did in this series, and I marked up an isolatable section. Yeah, that's the marking up of isolatable sections. So before you watch this, please try to watch that. And so the next step in the phase is to do a parts count, which is what this video is all about. So don't forget to like the videos, please. That's very important to us. And subscribe. Yeah, subscribe to the channel. So I marked up this P&ID in the last video in this series. So now we're going to do the parts count of the isolatable section. So you have to do a parts count, especially when you're going down the FARA, that's fire and explosion risk assessment, or the QRA, quantitative risk assessment route. So you're gonna have to do a parts count, which is what I'm gonna show you how to do in this video. So what we'll be doing, a parts count, is counting all the parts. It's a lot, right? Everything. But you have to look at what's in the isolatable section. Those are the parts you count, and then you put them in their various sizes. Now, we may have a little issue with this, not a real issue, but what I need to explain. If you notice, um, this table is in millimeters. Like when you see this 150 here, it's talking about millimeters. So that means the line is in millimeters. So 150 millimeters would be 15 centimeters, which would be about 6 inches. So this is a 6 inch line. That's what I want to say, because my pass count table is a bit different. It's in inches, and the drawing is in millimeters. So you need to have a table like this or something close to this, which is gonna. So what we're gonna do is look at all the equipment and flanges and instruments and valves and stuff like that. We're gonna look at everyone, and we're gonna try to count them, the number in each of all these places. So the first thing in this isolatable section, this P&ID is 3 drawings. It starts out here. This is where the isolatable section starts from, all the way here. This line goes on into, no, it doesn't come in here, does it? I think it does. And then it ends up somewhere here. Yeah, here. So this is where this isolatable section ends. But just for the ease of what we're doing, we'll just focus on this page so that I can explain. What I really want to get across is the methodology and how to do it. So what are the equipment we have in here? Well, because I want to look at this table, and whatever doesn't equip, because this table is really comprehensive, and all the equipments that you can find normally are written in here. So, and some of them we wouldn't need, so why not just get rid of them? So what the equipment we have valves, we have flanges, we have coolers, we have heat exchangers, compressors, vessels, and stuff like that. So at least whatever we know is not in here, we should get rid of. We don't have BOP stacks, we don't have Christmas trees, we don't have wellheads. So yeah, let's get rid of this. But you should have a table sort of like this. I think I should scroll through the table, and you can pause at any time to have an idea of what's in the table. You can pause at any time and create your own table, sort of like this. Yeah, I think that's where it ends. So just look at it. I may not be 100% accurate, but what I want to pass across is the how to do it, because normally you should actually print out the drawings and then work in it from the printouts, not just from a computer screen. So As I said earlier on, this first three, we're gonna get rid of them. Delete entire rows. Oh, yep. So we have compressors. Delete the. Okay, we could have filters. We could have expands. Okay, we don't have E compressors, so I can get rid of this. I should have done this before the video, but just so you have an idea of what this looks like. Flanges, heat exchangers, instruments. We don't have much here. Oh, okay. There's diverters, the gases. No, not used. We don't have peak launchers. We don't have peak receivers. Do we have pipelines? No, we don't have pipelines. But let me just leave that just in case. No, I didn't do that well. Okay. Let's go back here and see what. Okay. Yeah, get rid of this to the entire row. And then we have risers. We don't have risers here. Okay, we have vessels. We have some piping. Okay, so we don't have pipelines. We have piping. Okay, you don't be so stubborn. Get out of here. And then we have pressure, vessels, vertical, horizontal. Do we have pumps? No, we don't have pumps, but we have compressors. So get rid of this. Storage tanks. No, no storage tanks. No turbines. And then we have lots of different kinds of valves. I don't want those. So we start with, so now we're going right into the heater things. We start with this shutdown valve. We go into the table and try to find an actuated valve or an ESD valve. Okay, so that's this. We come back here. What's the size of this line? Uh, it's a 150 millimeters, so that's 6 inches. So we go to our table. So where does 6 inches fall into? That falls in bits. So this is less than 4 inches. This is 4 inches to 8 inches. This is 8 inches to 12 inches, 12 to 16. So it falls in here. So I could just put a 1. I'll keep on putting ones, sort of like a tally system, and then I'll count them at the end. So that's a 1. We have a 6-inch shutdown valve. We have a non-return valve here, or a check valve, which is also 6 inches. Do we have blowdown relief valve? Okay, we don't have a. Do we have a non-return valve here? No, manual valve, bleed valve, choke, check valve. Oh yeah, we do have a check valve, 6 inches. So this falls between 3 inches and 11 inches. You put in there 6 inches, perfect. And we go ahead. And here we have a flange, which should be this line. I wouldn't be able to know what this line, but I guess it's bleeding. It should be some sort of line to bleed the line. So this would be probably about a 2-inch line. If your P&ID is more detailed, please put that in there. So I can just say that's just a normal manual valve. So manual, yeah, that's a manual block valve, which is okay, bleed valve. So I can just say 1 in here, and then we go back here, and then we have this spec blind, which is called a spectacle blind, which normally we just look at as we look at it as 2 flanges, and that's on the 6-inch line. So those are flanges. Remember, I wish I could look for the picture of a valve for you. But flanges normally, valves normally have like two flanges and spec blinds. So this is on the 6-inch line, so I'll just say two flanges. Then we come back here, and then we have your vessel. So this is a vertical vessel. We come back here. Where's the vertical vessel? Yep, it's a scrubber, so not a separator. Yep, and that's one. We have one scrubber. That's what this is. I think they should have named it right. Yes, suction scrubber. So that's one. And then we'll count the instrumentation around it. So 1, 2, 3, 4. That's the holes for instrumentation. 1, 2, 3, 4, 5, 6, 7, 7 holes for instrumentation. So instrument fittings. Now the reason why we're doing all this is because we're gonna use all these numbers with the failure frequencies. We're gonna multiply them with their failure frequencies. So to determine, there's a document called OGP, or all gas pipelines, and there's a data of like historical data of all the pipes that have failed and the hole sizes and that kind of stuff, ignition probabilities. So all those, we're going to multiply these numbers by those failure frequencies. So we need to get all the numbers from here. Okay, and then we need to look at all the valves around this, which is 1, 2, 3, 4. So these are all some sort of connections for valves, but they're not actual valves. So I can also call them instrument fittings. Okay, so that's 4 plus 4. And yep, we're through with that. And then let's go to the top. Anything on this line? Okay, we have this. So we have a manual locked open valve, a PCV, and another manual locked open valve. This is 100 millimeters. That's that's 10 centimeters, which is about I'll say about 5 inches. This is 6 inches. No, sorry. 10 centimeters is about 4 inch. Yeah, it's 4 inch. It's 4 inch. This is 6 inch. Okay, so two manual valves, one 4 inch, one 6 inch. So let's go manual block valve, 4 inch, 6 inch. So that's two. Then we come back here, and then we look at this PCV, which is mainly 150 valves, well, 150 millimeters. So that's a pressure control valve, which we can call, okay, relief valve, blowdown valve, control valve, actuated control valve. So that's 6 inches, and that's one. And then we come back here. So that's this line we're taking care of all the way to here. There's some sort of removable spool in there. Okay, so we can call that. Can you see why you need to make this sort of? You can call that and should we? Yeah, we could. No, that goes under flanges plus 1. So can you see that why you need to print this out, mark it up, and then so that each line you do, you don't make a mistake trying to redo this. So we've come in from here, we've done this line across, we've done this vessel. Let's go to the top of the vessel. So let's look at this line all the way. Okay, what I can do to make this easier is I can change it to another color. Yeah, that would also help. So once it's marked up as, once I turn it to, let's say, make it really dark blue, I remove the opacity. Then we know that this is gone. We know that this is gone. Yeah, I think finally I just thought of that. That's a smart one. Yeah, okay. And then this itself, they're all gone. So properties, 100. So can you see that there are no hard and fast rules? So that we know that we've counted them and we don't have to redo them. So that's good. So now we're looking at this line. So on this line, we have a spec blind, which is 2 flanges, and this is 150 inch, so that's 6. Okay, plus 2. When it gets too much, I'll just sum it up. And then we have this plus 1. Okay, I'll just make that 3. Hope you understand. Then we have this locked open valve, and yeah, no more valves, just this valve, this valve. So that's 6 inches. That's 2 valves, block valves, plus 6. Okay, sorry. Why am I doing that? Oh, I was using the caps lock. So we've done that. Then we come back. Here we have another removable spool. 1, 2, 3, 4 flanges. So I go back in here. 4 flanges of 150, making this 7. Yeah. And then, yeah, now we have that. Then we are at the compressor. So we have to look, I'm not, this is, okay, so we'll go back to compressors. It should be a centrifugal compressor. We have one. We have to look at the, yeah, I think it should be centrifugal. And then, because it's spinning, right? And then, so I've got this, turn them blue. Yep. And then we come back here. I need to get this line from here all the way to train 2. Oh, well, there's no equipment on that line, so that's good. This, we have this removable spool, and it comes all the way to this locked open valve, and then this PSV. So what size is this line? See, that's why you need your P&IDs to almost be to be at more or less AFC to do this accurately. But so this is a line just feeding off. It's not a major line. It's going to the relief valve. So this probably going to be like a 2 inch, but I'm just guessing. So we can look at this flanges 2 inch, 1, 2, because it's a removable spool, 1, 2, and yeah, output flanges. So this is less than 3 inches, so I'll just say 2. Then we have the valves themselves. There's just a valve here, and this is like half of a valve, and like another half here. So because you're just touching this edge and this edge, so this is like 2 valves, more or less, half half and one whole one. So that's 2 valves, block valves. Although one is a PSV, I think I should just what's your valve? 1. And then do we have relief valve? Okay, so we have like a 1 relief valve here. I'll just put that here. It's an actuated relief valve, so we don't need to do that half. And yeah, come back in here. This half flange, I don't want to forget it, but I'll write it down somewhere. Then we have this lock close, and then this also. So this is your standby pressure valve. So you have a pressure valve here and you have a manual valve here. I'll go back in here. And all those lines are really small. So +1 and plus your relief valve. I'll just make this 2. And then we go back to our drawing, and yeah, we mark this up. Okay, we mark this up, and yeah. Properties 100% opacity. Can't see through me. And then you come to this line also. You have removable spool. This is 3 flanges. On what size of line? This 100. That's about 4-inch. So this is a 4-inch line, and that's flanges on a 4-inch line. So that should be here. That's 3 of them. Come back here. So that's just 3, 1, 2, 3, and it goes all the way sort of insulation into the spec blind 150. That's 4 inches, and so that's 2 flanges. You know, I said the spec blind is about 2 flanges, plus that's on 4-inch line. 100 millimeters, which is 10 centimeters, which is about 4 inches. And then we have this cooler here. So we'll go back. It's a fin fan cooler. Let's see, heat exchanger, shell, tube. Okay, so we'll just use the normal heat exchanger here. Okay, fin fan coolers, perfect. We have that here, 1. And then we come back in here and look at this removable spool, 1 flange in there. All this is like make it easier to remove this equipment and do some isolation and work on the equipment, right? You just flange it off when you remove it. Okay, and what's the size of the line? Okay, still 100. Okay, we have 1 all the way up to here. Okay, then we'll come back and count this. So 1 flange there, which is here. I'll just make this 5 from 4 to 5. And then we have block valve, we have non-return check valve, and we have shutdown valve. So shutdown valve, check valve, and manual valve, all 4-inch. So I'll start from block valve 4-inch. That makes this 7. Check valve 4-inch, that makes this 7, and the shutdown valve, that makes this 2. Perfect. And then we go. So all this should just mark them off as counted. You know, we still have a lot of instrumentation to count, right? So we counted the instrumentation up to here. So going from that, we have instruments here. Here, this is a PDIA, checking the difference in pressure between here and here, just in case this outlet gets blocked. So 1, 2, this is 3, this is 4, this is 5, this is 6, this is 7, and this is 8, this is 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 on the line, 20 instrumentations. And then there's this, okay, spec blind, 20 instrumentations. Okay, plus 20, and that spec blind on that 4-inch line, that's this. That's 2 flanges plus 2. Okay, and then Okay, we have this blowdown valve here, this BDV. That's like in ESD also actuated, and this line is most likely going to be about a 2" because it's on the line to the flare. So I would go for okay actuated. Is there okay? There's a blowdown valve here, so I'll just say it's a 2". We have one, and yeah, we count this one. So there's one here, which would be about a 2". So I'll put one more 2" valve. Okay, 2" valve. Ooh, +1. And okay, there's a normal actuated ESD here, which is where I should put this to. So I should get rid of this PLESDV valve and put it in here. 2. Yeah, perfect. And then come in here. This is a flanges, flange, because they're all closed. 3. Then this shutdown valve. Okay, I should have extended. This is a pressure relief valve. So we have 1, 2. I should have extended this here. So 2. Come back in here. 2 plus 2. And then we have the 1, 2, 3, 4, 5, and then the one I didn't count from before somewhere here, 6. 6 flanges. 2, 3, 4, 5, 6 flanges. Okay, 6 flanges, all less than 2". So yeah, I think I think we counted most of this page. So that's how we've counted isolatable sections. Oh, there's the liquid leg. Okay, then so you do this the same thing, your pressure control valve, your block valves, you do exactly the same thing up to this shutdown valve. So this is a 50" line, oh sorry, 50mm line, and that's about 2.5 2". So that's about 2". So 2" SDV, so which is 1, just have one of it. Then we have block valve here, so that's 2 block valves and the check valve, all 2". And the pressure control valve. Okay, pressure control valve, which is control valve 2". 1, 2 2" block valve, that's 3. And then what did we have here? Okay, I already wrote the ESD. So, okay, we have a check valve, a 2" check valve. Sorry, open that up mistakenly. 2" check valve, which brings us to 1 here. So this line is good. And then we have these 2 block valves here and the spec blind. Normally, when you have two valves that are closed, the shading inside here is what makes it different from here, and that means it's closed. When you have 2 that are closed side by side, then that means that we can actually say it's isolated. But 1 is not enough, so we can do this 2 2" lines, and okay, plus 2. So this line is all good. This line is all good. And then I'm to look at this line also. This is one more valve, which is 1. I should shade it, but just feeling too lazy to do that. Plus 1. And yeah, so we done the bottom. Yeah. So done everything here. Just this lines I could as well just smack them up. So we know that this place is entirely done. Oh, it's not giving me anything. I guess. Anyway, you get the idea. So we've done all that for here. So we've finished doing our paths counts for this isolatable section. So this that I've done, you do it for another isolatable section like this. You run it all the way through. We count from here, 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 count all the equipment, count all the instrumentation, just like that. This is the same. This is the same isolatable section. What was that color? I think it's something here. Okay. Yeah, so this is another isolatable section and you can count everything. So you have to number them or name them, each isolatable section, and you come out here and you count them. And you count each one, and this feeds into another part of the job which you would use to calculate the failure frequencies, because you open up your OGP and look at the failure frequencies for all this kind of equipment and multiply it by the number and the various sizes. So yep, that's how you do a paths count. Thank you very much for watching the video. This is Toby promoting safety engineering. Please like, subscribe the channel, and the next video will be explaining how you do that multiplication, OGP, and all that. Thank you very much. Do have a great one. Thank you. Bye bye.